Hello YouTube, welcome back to Platypus Presents Natural History of the Fauna of Maria. Today's episode, I've got something just a little different for you. As I was working on the list of animals that are present in the game and trying to come up with names and interpreting their evolution like I was for the fire bears, I decided that I needed some sort of framework to base my interpretations on. Now, in the real world, these interpretations are often based on the classification and evolution of the animals. So I decided that I needed to create some sort of working hypothesis about how the animals of Maria are related to each other. And that's what I've done here. So you can see it here. For now, I've only included animals that there is actual artwork for. So I haven't taken any screenshots and cut out the animals because I think that's probably going to be quite a bit of work. So as they release more of this concept art, I'm going to continue adding it to this classification and refining it, hopefully, in the process as well. So before I go through how I put this together myself, I'm just going to go over some of the generalities associated with these types of diagrams. Understanding these types of diagrams is a lot like reading a family tree. At the very tips here are the currently living or extant species. Or, if you want to continue with the family tree analogy, these would be, currently living family members. And you follow the lines back to common ancestors. So the root of the tree represents the ancestral lineages, and the tips are the descendants of those ancestors. And as you move from the roots to the tips, you're going forwards in time. When a lineage splits, as here or here, it represents a branch on the diagram, and that branch represents a speciation event, where a single ancestral lineage gives rise to two or more descending lineages. Furthermore, phylogenies trace patterns of shared ancestry between lineages. Each lineage has a part of its history that is unique to it alone, and parts that are shared with other lineages. For example, if we zoom into the, I think this is called the warbird here, if I remember correctly, you can see this part of the lineage here belongs uniquely to the warbird, and this one to the rex here. But this part of the lineage here represents the common ancestor of these two species, which could look something like one of the two descendant species, or it could look absolutely nothing like them. So without any kind of fossil records, we have no idea what this part of the branch will actually ever look like. So one of the most important things that people don't often realize when reading these kinds of phylogenies or phenograms, which this is more of a phenogram than a phylogeny, and I'll go over the difference in a bit, is that this is not to be read like a ladder from left to right, going from most primitive to most advanced. Because that would imply that evolution has some form of goal in mind, which it actually doesn't, although it might seem that way. But the unique thing with these kinds of diagrams is that you can rotate them around any node. So for instance, if we rotated around this node, we would have the pseudo-primate group actually over on this side, and these these hooved animals over here on the right. So it's one of the most important things. It's easy to misinterpret phylogenies to imply that some organisms are more advanced than others, but that's not the way that they should be interpreted. So as another example, if we look at some of these earlier lineages that branch off of the phylogeny, although they do share many of their traits with potentially older species, they've had the same amount of time to evolve unique characteristics as some of these younger lineages over on this side here. And along the same lines, you shouldn't read these trees as any sort of advancement. So, this primate group is not any better than, any of these carnivores or any of these hooved animals here. So, the way that typical phylogeny is usually constructed is you figure out which species you want to include in your tree, and then you construct a matrix of characters, as seen here, and the character states that each species has for that particular character. So for instance, taxon A here, this yellow beetle, it has an oval body shape as opposed to a round one. It's yellow as opposed to orange or pink. It has a certain number of spots. It has jaws visible. The head contour is white rather than black. It has no antennae present, and so on and so forth. After constructing this character matrix, you can then construct a table of pairwise differences between each of the taxa. So that's how many differences there are. For instance, between taxon A and B, there's only a single difference. And if we follow along between taxon A and B, we can see that they only differ in head color, and all the other characters are the same. This suggests that these two species are likely sister groups, having shared a more recent common ancestor than either has with any of the other taxa here. And that's what this represents here. So taxon A and B share a more recent common ancestor with each other than either of them do individually with any other species. And that brings me back to how to actually read and interpret these trees. When we have a number of taxa that all share a single common ancestor, so if we're going to focus on the flying animals again, we can say that this group here, these three species, constitute a clade. In this case, I've given this clade the name of Rostopteridae, and I'll go over what all these names mean later on in the video. But if we were to, say, include this, I think this is called the umbra wolf or something like that, if we can't include this umbra wolf by itself in a clade with these flying creatures, because then it becomes non-monophyletic, meaning that there's some descendants of a common ancestor not included in the clade. So if you did include this umbra wolf with the flying animals, we'd be looking at this common ancestor, and we'd be missing these three species here. One of the important things when constructing phylogenies, which is something that I actually couldn't do because this is just a video game, is figuring out the difference between a homology versus an analogy, or an analogous character. A homologous character versus an analogous character. A homologous character is one that is shared through common ancestry. So in this case, if we say, we'll look at this group here. I've constructed this phenogram with the I'd say guess, basically, with the hypothesis that clawed feet have evolved once from an ancestral state of hooved feet, and that all these animals have clawed feet because they evolved them from a common ancestor, and that's a homology. If we look more broadly at this tree, we can see that from basically the ancestors of all terrestrial life, all these animals have 6 limbs, with the exception of some secondary reductions like the mare hair there. So the presence of 6 limbs can be used to create a monophyletic group which contains all the terrestrial animals, because they all share that one feature by common descent. Now, an analogous character is a little bit different. For instance, because this is a game, it's very difficult to determine whether a particular character is homologous or analogous. But if, say, flight evolved independently in these different groups, if maybe perhaps the harpy here actually is more closely related to the rest of these carnivorous animals here than it is to the other birds, then the flight in that species evolved independently from these two species, and we would say that that character state is actually analogous, meaning that it had its own evolutionary origin. It didn't share the common ancestor of those groups did not fly, because that would mean that if the harpy were over here, then basically flight would have to evolve over here, and these four species would have lost the ability to fly. So these are kind of the subtleties that make interpreting evolution quite a bit more difficult, but a perhaps more down-to-earth example is a bat wing and a bird wing. They're both flying animals, but they've evolved flight completely independently of each other. So all bats share a common ancestor. So among bats, their wings are homologous structures. However, the comparison between a bat wing and a bird wing is an analogous structure, because these structures serve the same function but evolved in very different ways and under very different circumstances. So, when using a phylogenetic tree like this for classification, you want to name these kind of these monophyletic groups. And now this is something that is always a little funny, because many of you probably already realize this, but birds themselves are reptiles. And so the name reptile can't be used without including birds in it. Birds are most closely related to crocodiles than any other living animal today. And so if you want to include crocodiles in with reptiles and turtles in with reptiles, then you have to include birds as well. So reptiles is what we call a paraphyletic group, or a paraphyletic assemblage, because not all the descendants from a common ancestor are shared there. Another cool thing about phylogenies is, if we continue on with this bird and reptile example, birds are descendants of dinosaurs. And if we consider dinosaurs as a monophyletic clade, we have to include birds in there. So, I know it's not Thanksgiving, so it'll be cool, but when you eat a chicken or a turkey, you could really consider yourself eating a dinosaur. Okay, so let's go into how I've hypothesized that life has evolved on Maria a little bit, and then some of the names that I've put to some of these groups of animals here. So perhaps because life, as far as we know it, has only ever evolved on Earth, I've sort of based the evolution of Maria on a similar way, meaning that life basically started in the oceans. That's maybe not too far of a stretch for the imagination, because a lot of the processes in, as far as we understand, cellular metabolism here on Earth, are easier to perform in the water and underwater. You can get better gas exchange. You don't have to worry so much about osmoregulation, especially if if there's some kind of ocean that has high ionic concentrations. So that's why I've put the fishes here as the most basic of, or as the most ancient of lineages. And this particular species here, that's the, let me just look up the name for that quickly, the flatmouth shark. I've included that as a trichotomy here. So when we don't understand the exact relationship between evolution or between species, we create trichotomies or 4 or 5 cotomies in this case. I can't remember what the actual name is for that. So one species can only ever become 2 species. It can't become 3 species simultaneously. So when we represent it as such, that means that we don't know whether this species actually belongs to this clade here, or whether it belongs down here and forms a monophyletic group with the rest of these guys. But I've singled out the flat-nosed shark here as a little bit different because they actually have these pectoral fins, which may have been precursors to the limbs of the terrestrial animals here, though they only have one set, not the three sets that the rest of the land animals have. So maybe life on Maria evolved from some other deep sea creatures that perhaps don't hang out on shores, and we haven't discovered those yet. That's how I'm going to interpret it, at least. Next, the very first animals on land, or descendants at least from the very first animals on land, are these kind of weird, scaly, small creatures. Most of them are forest-dwelling, except for, of course, the needle-nosed giraffe here, I think is what it's called. Yeah, needle-nosed giraffe. And that makes sense. So when life first comes on land, it has to live somewhere moist, because it's probably going to help with respiration and thermoregulation as well. So that's how I've interpreted that. I've never actually seen these guys in the game. What are they called again? Arbillas. So I can't say too much about them. But these guys, of course, they have some fins and rays as well. So potentially, again, pointing to a link between this group as perhaps one of the most ancient lineages of terrestrial life on Maria. So these guys, as I said, none of these groups actually have hair. And then the next sort of big innovation in terms of animal life, terrestrial animal life, was the evolution of hooves. Now, this is something that I might correct for in future phylogenies, but I wasn't sure exactly. This basal area of the tree is obviously the hardest to construct without any other evidence than just what the animal looks like externally. But it seems to me that perhaps some of the earliest animals that didn't have hair, like these two animals here, they evolved hooves. So these are perhaps the last remaining descendants of a once diverse and flourishing fauna of perhaps dinosaur-like creatures, large, hairless animals. Here we have all that's left are a herbivore and a carnivore. So that again points to the fact that these are perhaps once much more diverse. And they're also both quite large in size. So what that suggests is, most of these guys are relatively small in size compared to the size of these two. So there seems to have been, at some point, a big leap forward, or a big leap upward, perhaps, in size. Which it was then, size becomes very variable among some of these later groups. But these two are both large, they're both spiky, they both have hard shells, and I would suspect that this lineage was probably, at one point, quite a bit more diverse. And here's a little hint, maybe to the game developers. These kind of hard shells, they leave very good fossils. So, yeah, that'd be cool, I think, if we had some archaeology and excavating tools that could uncover the lost diversity of this clade here. And the name that I've given here, the names that I've given here in red, I've sort of arbitrarily given at the family level. And this group I've called the Stratiosquamidae, which means stratio means stratified or with furrows, and squamid are scales. So it's the family that contains furrowed scales, which I think is relatively intuitive. So again, that's Stratiosquamidae. So the next lineages that we're going to be looking at are I've split into two groups here. Now, in this blue color here, this is above the family level, so I guess these might be orders. Families always have to end in IDAE. That's the taxonomic nomenclature for animals. Plants are a bit different. I can't remember what a plant family has to end in, but animals, it's IDAE. In orders or any of the other groups, there aren't any of those rules. It's just the family level that has to have that. So here we have two groups, the Ceratoundulata and Ungupodi. Ceratoundulata, undulata or undula refers to hooves. So all these guys have more or less some type of hoofed foot, or what looks like it may have evolved from a hoofed foot. Remember, even though it doesn't have a typical foot like a like a horse does, remember things like rhinoceroses are also undulates. So they have that same bone structure. They just have more kind of a leathery hoof. So that's what I think some of these guys might have, more of a rhinoceros type of undulate foot. And again, that's probably to help carry some of that extra weight as well. It's probably very hard to carry the weight of these guys on a purely keratinous hoof. So yeah, interesting fact for the day there is the horse hoofs are made of keratin, which is the same proteins that your hair and fingernails are made of. Okay, so Ceratoundulata, meaning cerato meaning horns. A lot of the members of this family do have quite prominent horns, and undulata as in undulates, which are hooved animals. And see, many of these guys do indeed have hooves. The first group within this order are the Dasyasquamidae, and these are a group of animals that I find are similar in that they have both hair and occasionally prominent, some sort of prominent scales or shells, but also have their first pair of legs modified. At least these two species have their first pair of legs modified for, well, I guess for combat for the most part. I mean, life is pretty harsh on Maria, so that's what those guys are for. And these two species here are they're just kind of very odd, and I can't really think of a good reason for why they'd be classified. I mean, the Maris horn, is that what it's called? Yes. So the Marisan horn barely has any hair except for that on top of its head, so it's almost completely bald. And to be honest, I'm not 100% certain where these two species fit, if they fit with these two guys, or if they should be on their own somewhere. I don't know. Maybe you guys can comment on that, what you guys think. Maybe this guy should fit with these guys, but this guy maybe somewhere else. I'm not exactly sure. But definitely has hair and definitely has hooves. So probably somewhere in this clade is what I'm thinking. The next family are the Dorsoviridae. And this translates to greenbacks. So dorso is the back of an animal, the dorsal side of an animal, and Virididae is just green. Although the Urudclad does not have a green back, the rest of the family does. So that's why I've given them that name. The relationships here, basically, these two look like, they might be most similar. They both have horns. That's kind of the only thing that I really had to go on. Again, without more detailed information, other than just kind of what they look like externally, it's very hard to tell, but they looked somewhat similar, at least to me. And these two, I've made as sister groups mainly because they both share this long tongue, But also, it's curious that this guy actually is not strictly a herbivore. He's also will attack very quickly when provoked. Sorry, his name is the Tapeto, and these guys are of course also predaceous. So it seems that feeding mode is not something that is very evolutionarily conserved. So throughout time, lineages will very frequently switch between meat eating and non-meat eating. That's kind of curious. That's an interesting little thing. That's not, you know, there's a lot of animal groups on Earth that do the same thing, so that's not all that surprising. Okay, so I think that pretty much covers the Cerato undulata, and the next order is the Ungupodi. It's a little bit of a tongue twister. Ungupodi. Ungupodi, it's clawfoot, clawed feet, and that's because these animals all share, for the most part, the fact that they have claws on their feet, with sort of more opposable digits, as opposed to these guys, which for the most part don't have those opposable digits, meaning, grasping digits. And within this order, there's I've created 3 families. I consider the Rostroteridae, which means rostro means beak, and teridae means, or teri means wings, so beak winged. Because I think all these 3 species all have beaks and wings. But even if they don't all, that's not too bad, because at least the most primitive member of this family, the harpy, has both beaks and a wing. Now I've considered these 2 species sister groups because they both have 2 sets of wings, whereas the most basal lineage, the harpy here, only has 1 set of wing. So it looks like along this lineage, a single wing evolved first, and then over time it must have somehow become beneficial for I guess the first pair. So first the middle pair of legs evolved wings, and then the first pair of legs evolved into wings after that point. The next group, the sister group to the Rosteridae, is the Edaxidae. And edax basically means bite. Yeah, I'm getting real creative here with these names. Edaxidae, the biting owls, these are really the most annoying, ferocious carnivores that we have on Maria. And I think the grouping here is pretty straightforward. I think most people would probably agree. We've got the umbra wolf together with the devil wolf, and they both have their first set of legs modified into some sort of grasping or attacking appendage, which they can project forward in front of their heads to help them take down some of the really the tough prey that you can see on Maria. And the second lineage, so what I'm thinking is these might be in the same genus, and I'll give them individual species names. These ones might be the same genus, different species names, and that'll probably be its own genus and species. Now this next group here, containing the fire bear, which last episode, if you haven't seen it, I gave the name Mesopediparus ignis. And so that contains the fire bear and the merryhare. What unites these 2 groups, for the most part, is the presence of very much reduced middle pair of legs. In my fire bear video, I hypothesized that these were simply vestigial, but I wasn't aware of whether that's the vestigial nature of the middle pair of legs was due to common descent or an adaptation for something unique to the fire bears. And in this case, looking at the phylogeny, it looks like this lineage is simply known for having its reduced middle pair of legs, which is the same with the merryhare, which are so reduced, in fact, that I don't think they're even modeled on there. They're just included on the texture. So there we go. That's the answer. The middle pair of legs are vestigial. It's possible that the muscles may have somehow been internally co-opted in the fire bear to help expel those fireballs, but again, without more evidence, can't say anything towards that end. And the final family that I'm going to be looking at are the pseudoprimatidae. Now, primate is really just the Latin word for primate. So I was trying hard to be creative, but I couldn't really come up with anything, that was primate-like. I just went with primate, and of course pseudo meaning, pseudo meaning pseudo. So these are the almost primates, or similar to primates. And the relationship here, I've considered the Domaca monkey to be the most ancient group within this family, and then the plesiogibbon and pilosogibbon and the other gibbon there are sister groups, and that's not that I think it's a pretty reasonable assumption. They look very similar, just slightly different body proportions. So, and then the final note is I couldn't really find a good place actually to put this guy, the Dalkav. Zoom in on him there so you get an idea. I haven't actually seen these guys in the game yet either, so maybe once I have a good look at them in person, I'll be able to better assess what's going on. But yeah, I asked one of the game creators about it, and he suggested it should go with this group, with the group containing the layer-back. But the problem is that they don't have hooves. So, it could be that clawed feet and opposable digits have evolved multiple times. I agree that the first pair of arms are modified, similar to other members of the layer-back group, but the claw thing, I think the modification of the first pair of arms is something that we've seen multiple times throughout the evolution of life on Maria, so we can't necessarily use that exclusively. What I'm thinking perhaps is more likely is due to the presence of the clawed feet, maybe some sort of outgroup for the Edaxidae. Who knows? Or maybe even more closely related to the Rostoperidae. I don't know. That's something that I'm going to work on. This is obviously a work in progress. This is valid as of alpha 0.62. There are animals in the game that I haven't included here, as I mentioned, because because there's no concept art available for it online. So those include like the underground crabs. I think those are called anteras or something like that. And that's going to require a whole new thinking, because I think that animal might be the only one that actually possesses some form of rigid exoskeleton. If I remember correctly, I've only come across them once, and they scared the crap out of me. So I'll have to go back and go hunting for them in their underground caves. That might be a completely different evolutionary lineage from these guys, which all seem to be vertebrates. That one seems to be the only invertebrate really implemented in the game so far. There's also those weird fish-like lobster things that I haven't included yet, but will probably be somewhere towards the base of the tree as well. They do appear to be one of the more primitive animals. They don't have any fur. And yeah. So, that's where we stand right now. These are the names. I'm going to put the names and their meanings in the description for this video. And hopefully you will stay tuned for future episodes. I think the next animal I'm going to be working on is going to be this big turtle guy, because I've come up with a really awesome name for him that I think you guys are going to really like. So, that's all for this episode, folks. Make sure to leave a like and a comment if you enjoy this. It lets me know that I'm going in the right direction. Alright, take care.